to you. Now, the phrase time machine was originally popularized by the author H.G. Wells, who wrote the book The Time Machine, in 1895. And so here we're seeing this man. He pulls a lever in a special contraption, and all of a sudden he is thousands or tens of thousands of years in the future. It's like a car, but for time as opposed to space. So if we actually accomplish time travel, is this the way we're going to do it? Will there be this special machine with all the right properties and we just, strap in our seat belts, strap us our cylinder and off we fly? Well, maybe. I mean, we certainly haven't thought it up yet, but who knows, really. However, today here, since this is Slooh, we're going to be talking about an aspect of space and the universe, and we're going to bring it down to Earth to see if we can make time travel out of it. So today, ladies and gentlemen, we are going to be talking about wormholes. And so what is a wormhole? Originally, the name wormhole for this object was made by a scientist who was looking at an apple with a worm. And if the worm chews right through the apple, it's a little bit faster than if it were to climb across that apple to get to the other side. A little bit of a shortcut, per se. So here I have a special handy dandy paper. And so imagine that this is our world that we have here. And we're flattening it down to 2 dimensions as opposed to 3, but bear with me a little bit. So we're here and we want to get to here. We want to get from point A to point B. And so we can travel along this paper and we can get there. Of course we can get there. It's just going to take some time. And we're limited in how quickly that we can arrive there based on how fast we can travel. But if we had a wormhole, that's a shortcut. So we live on this world and we can travel around this paper, but what a wormhole can do is if you fold it up, then you can get a special hole in that paper that can allow you to travel from point A to point B without having to travel the whole distance toward that other place. So this is a special shortcut. And so we can apply this to our actual universe here, where, if we're in one galaxy, maybe we can have a wormhole that has an entrance where we are here on Earth and has an exit all the way on the other side of the universe at some other galaxy. Like right now at Slooh, we have an array of live telescopes. And here in Chile tonight, we're actually looking at the UFO galaxy, which is 25 million light years away. And yeah, here we have it coming up live. And so this is a live view of that galaxy that is 25 million light years away. So going at the speed of light, the speed limit of our universe, we don't know of anything that can travel faster than that, 186,000 miles per second. It would take us about 25 million years to get to that galaxy. But with the use of a wormhole, we could get there in no time. It's just that shortcut right through the apple. You don't have to climb all the way over the apple. You can just barrel right through it. So this is an amazing thing. And it's something that has fascinated us in terms of science fiction a lot recently, particularly if you're familiar with the movie Interstellar. They use the concept of wormholes. And we actually have this amazing tool that we can actually show you to visualize entering and exiting a wormhole via the use of wormholes, and via the use of space travel through wormholes. And so this is actually made by Pim Schurz. And so here we are, we're looking at this this amazing sort of world that's made by Pim Schurz. And if you want to explore this world, I'll actually give the link in the chat box after the show so you can see it for yourself. And so here we see Saturn and this sort of strange object right next to it, and that's the wormhole. And so in the movie Interstellar, there was this wormhole next to Saturn that the main characters used to fly to this whole supermassive black hole named Gargantua. And here we're traveling closer and closer to that wormhole as we speak. And boom, all of a sudden we are 10 billion light years away in this whole place that is right near this giant supermassive black hole that's known as Gargantua in the movie. So we're actually just looking at the wormhole part of it, but you can actually fly to the black hole Gargantua if you ever get the inclination. We're not going to do that here today because it's a bit far away. But if you ever want to use this, the amazing Pim Schurz made it, and it's pretty fascinating to look at. But you see that we just made a quick hop, step, and a jump from one point to the other, from our Saturn and our solar system. And then all of a sudden we're at this place with Gargantua, 10 billion light years away. It's really an amazing, just complete leap in terms of space. But this is space. This is not time. We're talking about one place in the universe versus another place in the universe. So, what about time? I said wormholes might help us there. And yeah, we're sort of getting to that. This is just a little bit of an introduction. So, while this property of a wormhole can let you travel in time in the sense that you arrive at a spot before light could speed there sometimes, it isn't quite the same thing. But wormholes, they connect a particular point in space. So there's an opening at a particular place in space and also a particular place in time. This is what gives them the potential to be time traveling mechanisms. So just like you consider your physical location and in coordinates, there can also be time in coordinates. Uh, so to make that wormhole a time machine, you have to get your entrance to a wormhole at a different point in time than your exit. And so the question here is, how exactly do you do that? Well, this is where the speed of light comes in. So, say that we have a pair of twins. Some of you might know the twin paradox. So, one of these twins is an astronaut and is heading out into space, while their other twin remains back on Earth. They're not going out and they're not traveling through space. And the astronaut that is going up into space is going in a super special spaceship that can travel nearly the speed of light. This is the universal speed limit, really, really fast. And the funky thing about traveling near the speed of light is that it slows down the passage of time for you. If you're traveling really close to the speed of light, you will feel like less time has passed than for somebody who is traveling at slower speeds. And so, as the twin is out in space, flying through the galaxy at these super fast, approaching light speeds, perhaps let's just say only 5 years pass for him. And while on Earth, the same amount of time seems to take about 50 years. Now, all of a sudden, one twin is a lot older than the other, just because of how much time passed between the two. And so now, what if both of those twins had one side of a wormhole that they were carrying along with them? That gateway that you see, artist conception on your screen, a gateway through space. What if they were carrying both entrances of one wormhole along with them? One stayed on Earth, the other went in the spaceship with the other twin. Now, these two ends of the wormhole, since the twin was traveling close to the speed of light, are going to think they're at different points in time as well as in space. This is the amazing part. So the wormhole in space only thinks that around 5 years has passed for them, while the wormhole on Earth feels like 50 years have passed. And so, if the twin in space enters his wormhole, where only 5 years have passed, that twin will exit the wormhole back on Earth, where only 5 years have passed after they left, or 45 less years than the time it took on Earth for them to make that journey. And if the twin on Earth enters the wormhole, where 50 years have passed, they will exit the wormhole next to their space traveling twin, where 50 years have passed for that wormhole, or 45 years after the space traveling twin had finished their journey. Now, this is a huge mouthful and all really super confusing. I know, absolutely. So, to put it simply, if the twin traveling really fast in space goes through their wormhole entrance and out and exits out the side of the wormhole in Earth, they are going back in time. If the twin on Earth goes through their wormhole entrance, the one not in space, and exits on the side of the twin in space, then they are going forward in time. And so this is a mechanism for time travel. But at the same time, it does have its limits. And so one limiting factor is you're not able to travel outside of those two specific points in time that those entrances and exits to the wormhole indicate. There's no magical lever like we see in H.G. Wells's The Time Machine, where you can say, okay, I want to go to this specific time, push the lever forward that way, or back in this specific time. But at the same time, it is a way of time traveling and going from one spot to another, just like that. Now, how do we make these things? That's a question. Because as you're walking around, as you see buildings, you don't necessarily see these giant sort of physical holes that take you to other places and warp you. At least that's not common for me. Is all I'm saying. But so we haven't found any of these things naturally occurring. And one common theory is actually that wormholes, while math says, hey, these guys could exist, that they aren't exactly self-supporting and would collapse pretty quickly if they were formed. Unless, and now this is getting into some crazy stuff again, they were supported by some types of what is called exotic matter. And this is crazy stuff that has like negative mass and all that. And we're not going to get too deep into that, but let's just say it'll be a little bit difficult to master the art of time travel with wormholes in terms of creating them. We're not quite there yet, but scientists have taken a step in that direction. They've made something that is not quite, but it approaches something like a wormhole for a magnetic field. And so a magnetic field goes from one point to the point to another. But with this magnetic field wormhole that they created in their lab, the part of the journey, the in-between journey, was invisible from a magnetic point of view. So you see the starting of the magnetic field and you see the ending, but you don't see the journey. And I quote from scientists here when they say that that middle point was when the stuff was going through, as they say, an extra special dimension. So that's similar to what wormholes for people traveling through, what we're idealizing is that they would help us move through the universe, and time travel would be similar in that we would enter at one spot, exit in the other, but that journey wouldn't be there. We'd be invisible in between that and wouldn't actually be going along that apple. We'd just be going through the apple. So again, we're not quite there, but we're working on certain things and we're seeing what is possible. There is, potential from this interesting little magnetic wormhole that we see here. And so, one thing that I think of in terms of wrapping up this topic here tonight, that the interesting thing about time travel, and in particular, other fantastic developments that we have in the sciences that keep popping up year by year, is that they never seem to quite end up as we imagine them. About a century earlier, we started with a man in this giant sort of car-like time machine with a lever, and today we're working more with gateways to other worlds across the sides of the universe. It's not a man pulling that lever anymore. It's two sides of the same coin, just on very opposite sides of the universe. And so if we manage to master, the art of wormhole time travel, will it be like how we expect it to be today? Or will it be different? And how should we use it? Because it is limited compared to other types of time travel that we've considered and discovered in our science fiction explorations. So if you have ideas, I'll be around in the chat after the show and we can talk all about it. We can see, what we all think about this really sort of mind-boggling type of issue. But thank you so much for tuning in. It's been so fun to talk to you guys again today. Always love seeing you around. And I can hope that I can see you again next week, same time, same place with Down to Earth. Always on Tuesdays, 9 p.m. Eastern, 6 Pacific. See you again.